All right, Jenna, this is for you. Here we go. What?
Parker's not here.
Parker, where are you? 0. Okay. All right. So we've done exponential graphs. So a times b to the x plus, I'll say plus k. If your base is greater than 1, what does that graph look like? It's a growth curve, right? What's the horizontal asymptote? It's k, whatever k is, right? So this is your HA. This is a growth curve. There's k. Now, it could be moved around, but in general, that's its shape, right? Okay. If your b value is less than 1 but greater than 0, in other words, it's a proper fraction. Do you know what I mean when I say proper fraction? What do I mean? There you go. K is still your horizontal asymptote. But it is a decay curve. So it looks something like that. All right. So those are exponential functions. And then we have the log functions. I'm just putting in the important values that I'm going to focus on. Okay. In the exponential graph, the k value gave you the horizontal asymptote. What does a log value have? Does it have a horizontal asymptote? It has a vertical asymptote. What value in here do you think gives you the vertical asymptote? The h value. Okay. So the h value is your horizontal, or sorry, vertical. X is equal to h. That's your, when I say VA, are you okay with that? For vertical? Vertical asymptote, HA horizontal. Whatever your h value is your horizontal or your vertical asymptote. The B also tells you if it's growth or decay. Okay? So if your B value is bigger than 1, growth or decay? Growth. So then your graph looks like this. And I'm not putting a k value in because it's hard. You can't really represent it on a general graph, right? Because it's just shifting it up and down. So all I'm focusing on is the base and the h. And then if your b value is less than 1 but greater than 0, in other words, proper fraction, same idea. Your k value or your h value is your vertical. Except it's a decay curve now. So the graph looks like that. We okay with that? All right. Everybody got that down? So this is what I would ask you to do. Sketch this graph. Log base 1/2 x plus 2. I'm actually asking you to sketch it. Like, please. That includes you, Parker. Let's go. And Jenna. Is that what we got? No? Why is my vertical asymptote at -2? Because the h is always the opposite, or what makes it is 0 in the brackets, right? Remember that? I just drew it. I'm not asking for the y-intercept because you have to use log. Like, we'll be able to solve for it in a bit. We're not there yet, so I'm not worried about it right now. Okay, I'm worried about, can you get the vertical asymptote right, and is it growth or decay? That's what I care about. Okay, one more and then we're done this lesson. Use it. How's your grandma's lawnmower?
It's working.
It's good. It's working.
I know this week's been a problem. I worked on my race car for like 2 in the morning. First car. It's actually grandma's lawnmower. It's kind of grandma's lawnmower. Yeah. That's the challenge I've owned for like 3 years.
Show the people. Are we ready, peoples? And boom. Is that it? Remember, you have to factor out a 2. So you get x plus a half. So the h value is -1/2. It is growth because the base is 3. Remember this? Okay, this is what I expect you to know. On a log graph, be able to draw the vertical asymptote, and if it's growth or decay. For an exponential graph, that's not an exponential graph. For an exponential graph, be able to do the horizontal asymptote, which is k, and if it's growth or decay, and I can ask for the y-intercept too, because that's fairly straightforward on that. It's a little more involved in a log graph, but we're going to start to solve log equations today, so then we can solve this. Okay? No, we're skipping to the next chapter. Because the next chapter is solving. So instead of breaking it up, we'll just do it all together. Are we good? That's lesson 8. Done. Parker, Jenna, enjoy. Say goodbye to him, everybody.